Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 325, number of great partitions. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this this problem. So this one I feel a little bit sad about, to be honest, in retrospect. But I feel like I did okay. Like I solved this, but the thing that I feel a little bit sad about is that, to be honest, I had most of the idea initially, but I didn't believe in it. And I guess maybe, sometimes you should just test things and kind of, YOLO it. But this is let me just be clear. This is a very tricky problem that requires a lot of experience with dynamic programming. I mean, you could figure it out. And it's definitely at least a problem that you can figure out, meaning that if you have some base level of dynamic programming, especially for this problem, knapsack problems with dynamic programming, you should be able to solve this in some time. Maybe not during contest time. This is a little bit tricky. A lot of people didn't get it, but you should be able to solve it in theory. Maybe, I don't know. But we'll go over all the pieces that you need. And first of all, I'm gonna just because I want to write something else here to kind of illustrate. But first of all, the first thing to notice is the mod. As usual, you have to sing the mod song. And so I'm going to first explain this by kind of doing the naive dynamic or memorization, really, right? I'm not going to go over memorization in this video. This is the contest. This is a Q4. I'm going to assume that you know how to memorize and why you memorize. In fact, in most of my other videos, my daily problem videos, in the last week even, I go over memorization a little, at least, enough time. So I'm going to just assume that, that at least for this problem, we're able to solve it. So here we have a count. The naive thing to do is just like index, and then you have two groups, right? So I'm going to call them left group and a right group. You could say group 1, group 2, it doesn't really matter, right? And then this is pretty, if you don't know how to do this, I think you should, because it comes up, like a variation of this comes up a lot, though as you can see, we're now doing harder versions of this. But if we ran out of numbers in the index, of course, then we just return 0 if it's no good, but if left is greater than k and right is greater than k, then we return 0, right? Or we return 1, right, for one number. And you could write the left and right in a couple of ways, but basically the idea is that you either add the number to the left or the number to the right? So you have index I plus 1, left plus num sub index, right, and then you also add that to the count of something like this. Oops. Right, so this one I hope I don't have to explain too much, and of course you have to do a mod, but I'm just going to skip that for now. I mean, modding is just, you could just mod here, right? So this would be a good solution for an easier problem. However, there are a couple of problems with this one, right? The constraints. One is that because num sub I could be 10 to the 9, well, these numbers will get too big and then you end up not caching any of it. So that's one. Two is that, so that's one, well, okay, let's just say that's the thing you have to worry about, right? Well, how can you rewrite this in a different way? The answer is just, well, I mean, maybe there are a couple of ways you can write this in a different way, but now instead of counting from 0, because here you may just say return count from 0, left is 0, right is 0. Let's say we can count down, right? Same idea, but now, because of counting down, maybe this is a left and right still true, and then maybe is equal to 0, and we'll go with this in a second. But now you have this left minus minus, right? And of course here you can clearly see that you can also if this is negative number, then it doesn't matter anyway. So then we could just do like max it to 0. So that means that if the number is negative, we could just convert it to 0. Bam. We just made an optimization. The left and the right could be some huge number, but now left can be only bounded by k, which is 1,000, right? So in the worst case, index is going to be 1,000, left is going to be 1,000, right is going to be 1,000, right? So of course, if you do the math, That's still not great, still no bueno, right? This is still a billion, which is too big for our purposes. So one thing that I sometimes do is that, and this is kind of a tricky thing, but you can kind of prove, and for me it took a long time to be honest, but you could kind of prove that one is a reflection of the other, right? What do I mean by that? Well, let's say one is uniquely determined by the other, I think, kind of. We'll go over why this isn't the case for a little bit, but basically you can say that, okay, maybe, right is equal to the sum of the numbers up to the index minus left, right? And the reason, and this is basically saying, okay, we use all the numbers from 0 to index -1. So maybe I think my bounds are right, but something like this, right? It could be off by 1, but you get the idea. That index, so we have all these nums of numbers. So, and we not have index, right? So that means that because for every number in the nums array, we have to add it to the left or to the right. That means that another way to write this, maybe this would have been a little bit better to write first. Left plus right is equal to num sub all the way up to index. Maybe not including the index, but up to the index, right? So left plus right is equal to, so the sum of the indexes, right? So hopefully that makes sense. And then therefore, you can define right as, the sum minus left, right? So then now, because you can do this, now we can reduce one of the dimensions, and now we're in a good place, kind of. Not quite yet. There's one more thing up the sleeve. So yeah, so this is good because now this is 1,000 square. There are two things to do, I guess. One is that this sum is going to be really expensive. We go every time, but that's okay. We can use a prefix sum to save this. I'm not going to explain that part. Hopefully, if you're at this problem, learn a little bit about prefix sum and practice that and so forth. So that part we can do. But the other problem is that this can only go up to only go down to 0, right? Meaning that if you go down to 0, so if you have, I don't know, let's say your array is something like, 1,000, and then 5, right? Let's say we put left, this is on the left, and then we have 5 on the right. This is clearly not a good partition, but because of this max thing, the index would be, well, I guess the index would be the last one, but left would be equal to, in this case, would be 1,000, and then right would be 1,005, even though technically we actually want this to be 1,000, but this just kind of, removed it from us because we took the maximum thing. So what you want to do here is kind of tricky, and that's what I'll show in a second. But I hope that for now, let me pause for 2 seconds. One for me to catch my breath, but also for you to kind of understand it up to this point. If not, make sure you go back and rewatch it first, or go to the Discord and ask a question first, because I think this is these are things that will come up in other dynamic programming problems. The hard part is putting all these pieces together into one dynamic programming solution, and it took me a long time, right? To be honest, it took me half an hour. Maybe I could have gotten it earlier, but the truth is I didn't, right? So yeah. So the thing that you can do is break it down to case analysis. And I don't know if it's smart. I don't know if that's the only way. A lot of people might have done it differently. But first is, well, I mean, I think this is actually not necessary, but that's fine. And I do a prefix sum here, right? And then the idea here is just go through all the cases of if left is greater than k. So basically, we want the invariant that we want to do is left is less than or greater than k, right? yeah, or maybe the invariant that that's not technically true, but the invariant that I wanted to do is if left is greater than equal to k, then right is greater than equal to k, but right can be greater than k and left is less than k, right? So that's basically the idea that I have for this problem, the invariant that I want to keep for this function. So basically, and then after that, I just go for the cases. And yeah, basically for the right side, I did the prefix of order left. If index is greater than n, then this is same thing that we've seen before. Otherwise, if they both are greater than k, then it doesn't matter if you go left or the right. So to be honest, you can actually, because it doesn't, I kind of did this in a lazy way, to be frank. But basically, if there x numbers left, then this is just 2 to the x modded, right? So actually, you don't even need it to do it this way. But I was just kind of like, whatever, just memorize it for future. Yeah, I mean, this is just a for loop anyway, right? So it's fine. Or like a for loop, an unrolled for loop. So yeah. Otherwise, as we said, if right is less than or equal to k, we want to make sure that left is still k. So here, so we either put it on the left, which means that we add it to the left, and then you have this thing here, or we add it to the right with the knowledge that the right side is still greater than k, right? Yeah, and of course we have to make sure that this is at most k. So that's basically if the right is greater than k. And because of this one-sided invariant, we know that there's only one more case because there's no case where left is greater than k and right is less than k, right? So then we try to put a number. So this is the case where left is less than k and right is less than k, right? So then now with this number, we go, okay, let's try to add it to the left. And that's this part, right? If left goes over k, what we're doing is we just swap, right? That's basically that's the kind of the idea that I was proud of. I don't know if there are different ways of doing it, but the idea is that, okay, well, if adding this number to left makes it the case, then we just swap it, right? Because then now the new left is going to be the right, and then the new right is going to be left, but that's over k, so we don't care about it anymore. So that's basically the idea. And then the other side is, otherwise, if it's less than k, we don't care. And of course, in this case, the right is still less than k, so the invariant holds that this is true. So yeah. Otherwise, this is adding it to the right, and because if we're adding it to the right, we don't care, we don't make any changes to the left, so that's why this looks like that, even though it looks a little bit whatever. But yeah. And then of course remember to mod, and then return the total, and then remember to kick it off from 0 and 0, and there you have it. This is a very tricky problem. It took me a while. I had most of the pieces. I just wasn't confident that doing this case analysis is good enough, to be honest, for a while. And I kind of honestly only did it because I was like, I don't know, I ran out of ideas for a long time. And you can watch me solve it live. I kind of ran out of ideas for a long time, so I was just like, all right, let's just try this thing. At worst, well, I still don't know the answer, right? So a little bit of YOLO and hoping to prove the bounds. I mean, I knew that it could be right, but I was really, yeah. And I also, additionally, I did have some PTSD about doing it tops down because Leetcode with 1 million has always been an issue lately. So yeah. Anyway, that's all I have for this one. Except for the bounds, let's go over the bounds. So index is, as I said, could go up to 1,000. Right or left can also go up to 1,000, but this is of course, oops. And this is of course k. So this is going to be all of n times k, time and space, because for each of those we just call a constant number of operations. So yeah. All of n times k time and space, or 1,000,000, or whatever you want to say it. Yeah, that's all I have for this one. Let me know what you think. Yeah, and you can watch me solve a live in contest now. So many wrong answers today, so I'm glad that one kind of got me through a little bit. Q3 is the easiest farm for me today so far. Number of great partitions, okay. 8 people solved this. So I have to think about this, and I'm catching up. Positive. So we have positive integers and integer k partitioned in a 2-order group such that each element. Okay. So basically, we want to partition mod song. Mod. Do the mod. Okay. Partition is greater. The sum of elements of each group is greater than or equal to k. And there's 1,000. Oh, k is 1,000 as well. So we could do like a. Is it not naive? It's just left away, right? This is kind of tricky for me to understand. Oh no, numbers of length is that, but k is sum of elements of each group. Yeah, k is only I don't get this part, but okay. I think this is pretty straightforward, but I'm just worried. I think like I want to do it top down, but Leetcode is being silly, so I'm just trying to think how to do it. Because top down I could finish in 2 minutes. So we have. No, can I? No, because that'll be index kk. Except for not actually, because yeah, I think index and k is fine. Okay, let's just do it top down, and then if we have to, if we have to, right? And then we have a prefix sum. The sorting doesn't even matter. Did I sort? I don't think I sort, but it doesn't matter because it doesn't matter. What am I doing? Remember cache Larry. This one's a little tricky actually. Because I want to say that right is equal to prefix of index minus left, but then if we want to bound left by 1,000, then that is actually tricky to get precisely, because you may misattribute the other numbers. Maybe this is harder than I expected then, but yeah, okay. Is it dark? I mean, it's 1,000. No, it's a. What won't be it? Is there that many possibilities? It's just prefix sum, right? Let's just try it. We don't need this. Then 1, and then this is just whatever. We'll figure it out later. Then I think this is n plus 1. Okay. then basically this way. So this is the number of count. We have to do the math on the final number, I guess, on the sum, on the k. Is this good enough? I don't know. People are getting it though. If j num sub I -1. This would be equal to dpi -1. But this is like, I don't know if this. Right. But so that's the number of ways to have it one partition, right? So that's the like very naive thing. How do we do it for the other side? Because you could have like, I don't know, like 101. Just because you reach k on one side doesn't mean anything. Greater than or equal to, okay. So then how do we check that? The check is delta. Now you can't do the delta that much though, because it's 10 to the 9. I think we can cap each number by, okay, maybe we can do something like this, where, yeah, okay. And then, and now maybe we do this times 2. Because then now and now it is assumed, so okay. Because then because you have like how do I mean this is definitely an optimization, but I don't know what to do with it enough, because now just because you have a sum on one side, does that mean you have a sum on the other? We have 2000, but then for example you have 1000 and then you have to do a lot of counts. But then on the other hand, Is it divide in the middle or something? If only I didn't spend so much time on the first two. A lot of people got that one too, though. So. Can I prove one thing with the other? It's just a number of ways that one side can. You want to say that it has enough. And the other side. And it's like k squared and then k cubed. That's not good. 1,000 cubed is not good. How do I fix this? How do I get rid of a dimension? I mean, just like that left-right thing. Then this becomes 1,000,000, and then it becomes the same thing anyway, if we just let it sum. What am I missing? We want the difference, but you can't DP on the difference, can you? No, the range is too big. You just choose all the powers of 2's, and then you would add and subtract, and that would be 2 to n. I think you could do it that way, unless I'm really wrong. Can I sort it and then it doesn't matter? No, then you just have like 1,001 numbers or ones. And you still have to balance it anyway. If only I didn't have 3 wrong answers already. Yikes. Pretty quick on Q3 though. Can I infer the other thing from this? I thought there was an easier way to do this, but a lot of people are getting it, but also not that many, to be honest, since everyone else got the other 3 much faster. This is just standard dynamic programming, but it's not quite right, is it? So you have to do I. There's either plus or minus. But that could get like pretty big pretty quickly, even if they're all distinct, or even if they're all not distinct. Because then yeah, because every number doesn't doubling, and that gets big pretty quickly. Right? Yeah, guess so. Like you have ones, and then you and that's the same complexity of the top down anyway, just done a little bit differently. No, because you have just k 1,000 and then just 1,000 ones, and that would just be really slow. Trying to think whether there's like a way to go about it. Just wait, let me see it. And there's 1,000, so there's no like divide the middle kind of thing. Is there? Well, you have to do the count anyway, so it's not even just like looking for one solution. I'm stumped. Is there anything non-DP that I know of? What if I sort the list? Does that do anything? I really do the max. I think this thing is fine, but I don't think sorting it matters. Maybe we could use the prefix sum in a good way. I'm gonna try. I don't know. I'm gonna try to do it. I don't have the visualization for that for now, but I don't know if that makes sense. And we just return, whatever, return. I think this one doesn't actually matter. It's just 2 to the whatever, to the, otherwise. Otherwise, left is by definition not k. Then right, if right is then k, then we can go index left plus go index plus 1, and then left. Well, left, but then it's also left plus num sub index, and we want to max this by k, or min this by k actually. But we want it, okay. And then else, they're both not it. Then we want to do okay. If okay, then we want to swap it so that the math is easier. Because, okay, and then else we just do. Okay, and then now we add it to k, which is just to the other side, which is just this. This index are bound. Of course, I should put something like that in there. 0. Oh. Well, worth a try. I don't know where I got 6 from, but yeah, got this one right. We're making progress. Because we have to be really careful about the left. The left should never be greater than k unless this thing is. It is fast enough though, right? I think that's what I care about first. 500, right? Length of nums. No, that's actually pretty fast, if this is right. So we just have to get it right. I think the idea is right, but maybe not. So I have 4 for the first one. Oh no, 14 for the first one. Why do I have 14? Okay, let's take away this case. Let me put it somewhere. Okay, and then, okay. And we could put it out. Everything is modded, okay. Okay. Oh, because I guess we early terminate on the other ones. I don't know what this would do. Okay, so next level, we have 4. That's pretty good. If we okay, but what if we had the other ones? Actually, this is really weird. Should have at least 1 and then 1, right? What is K for this one? 4. I did not sort, but actually, let me double check. 0, 0. Okay, 1, 4. Why? Oh man, that's why. Okay, that is a silly mistake. 602. Okay, I don't know that this is right, but well, let me get rid of some prints, and then I'm just going to YOLO. I mean, it's right for this, but is it right? I don't know. Probably not, to be honest. But well, you wouldn't see if it's fast enough. Okay, I actually thought about this idea for a long time. I didn't think that was going to be good, but I have a lot of silly misses. How many people did get it in the end? Wow, a lot of people end up getting it. I think I just didn't believe in myself on that one, to be honest. I probably should have gotten it, but because I was thinking about those lines, but like very early, but yeah, I just didn't believe in myself, which is kind of maybe it's just one of those days. Need time, because I had that idea, but I didn't really draw it out. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest or this problem. I'll see you later and take care. Bye bye.